I guess I'll just start since it's time. No one told me otherwise. So, my name's Tom. I've been doing video game development the last couple of years. My biggest unfinished art project right now is a video game about waterfalls. The premise of the game is there's some kind of like environmental catastrophe, climate change apocalypse. Global warming has made the land bare. Plants are not growing. It's just a big rock. So you have to run around and figure out how to restart waterfalls, water flows, and get plant life going again. Do some soil remediation. In the real world, I lived in this area, the Portland area, since '94, and fortunately there are tons of waterfalls all over the place to get source material, source photos. There's so many in the area that if you go to one waterfall every weekend, you would still take years and years to actually see all the waterfalls around. For instance, there's Multnomah Falls, a really huge two-tier one. The Plunge Falls. Next to that is Triple Falls, where the water like splits up into multiple streams. Twister Falls, where the rock like focuses the water to flow in certain ways. The one on the end is called Tunnel Falls. It's at the end of Eagle Creek, out in the Columbia Gorge. You can't quite see it in the photo, but there's a tunnel blasted in the rock behind the waterfall. And that was constructed by a jobs program in the 30s called the Civilian Conservation Corps. And I wish they'd bring that back after the current government is confirmed. More types of waterfalls, huge ones that you can walk behind, ones that fall down rocks, ones that flow over strange terrain, and water changes through the year. Like this is the same waterfall. If you go to it at a different time of year with those bigger snowpack, all right. Yeah, so this is the same waterfall. One is in from the winter after there's been a lot of rain, and the other is from this kind of late summer. So if you want to represent waterfalls, there are just so many different factors that you want to take into account. And as I've been going out to see waterfalls, this is the Columbia River Gorge. Portland's kind of down here. Each of these little dots is one that I visited over the last couple of years. I've been making this map using Leaflet, which is open source JavaScript-based, web-based mapping software. Let's see. So this database I've been slowly making to keep track of interesting stuff I've seen while hiking around. This stretch is about 50 miles long. Every time I think I've seen all of the waterfalls in the area, I go to a bigger list. Like this one is waterfallsnorthwest.com. It's some people that have been putting together this list for like 20 years. So they have this vast database of all kinds of obscure ones, popular ones. A lot of waterfalls are on private land, so many of these things you can't quite go visit in person. But there's just so many. This site is a little odd. Hopefully it's just, they're trying to make a database publicly available, but they don't make the list, their actual database data publicly available as far as I can tell. So it's a closed database, but you can pull up information one by one. It's not quite open data. And this is the Oregon side. I think the website is so old that you can only see one state at a time. So their mapping solution could use a little updating. There's just so many little waterfalls here and there. On the subject of waterfall lists and open data, that says Waterfall Survey is kind of a spin-off of the World Waterfall Database.com. It does not, same thing, you can't quite download the data yourself. You have to click through their map interface. You might notice a couple of flaws in their display technology. It's like using an older Google Maps thing. It's kind of artifacts. When you first bring it up, a big box comes up and says, "Do you understand this is for development purposes?" It might not work. Another reason to choose an fully open source stack instead of one that's only temporarily free, like through Google services. There is one database that I found for waterfalls that is basically open data from the USGS, it's pretty thorough for the United States, but it's only about the United States. And so far, this database has not been wiped out by my country's current government, but the day is young, you never quite know. These larger maps kind of inspire me as an artist to not just do more hiking, but also make kind of experiential maps. A long time ago, before people had a very thorough map of the world, they had to like piece together kind of, it wasn't here's 50 miles exactly, you have to go in this direction. It's more kind of vaguely, here's this thing, and here's a little picture of what you might find there. Or here's a monster you might encounter or whatever. I kind of wish that in this, we have so much data now to bring back this kind of more experiential data, kind of more personal visions of what's going on in the world, I suppose. My map to that end is still just a few sketches in a book, so I'm getting there eventually. It could eventually turn into a little mini map for a video game, for instance. Many of the parks these waterfalls exist are under attack by politicians, hell-bent on logging surrounding areas, otherwise privatizing parks so they can be gouged for short-term profit. The premise of my video game is suddenly not so far-fetched, I guess. Public land is, in my opinion, kind of a distant cousin of the open source ethos. It's the whole concept of a public commons. I think that's really under attack. It's the whole idea of a public commons where anyone can experience or use data or land or whatnot. I always used to joke that when society collapses, my art prices go up, so prices might be going up. I want to be part of like collecting and building tools that kind of help out and record ecosystems and land and wildlife. There's some video games already that's kind of are like ecosystem simulators. My goal is to be part of things like that, and my waterfall game I'm hoping to fill a little niche for like waterfalls and rivers specifically. Anyway, back to less depressing project details. All the all the photos and hiking experiences I've been accumulating gives a huge baseline for what should be renderable as a digital waterfall. For instance, when there's water splashing around, there's you need to know about a 3D path, like where the water is falling, how water is reflecting light, how water is refracting light, bending light as light passes through layers, multiple layers, multiple types of waterfalls. Splashes, how things are splashing on the ground, how water at the bottom is like bouncing around. And I never forget that if you're out hiking, you always see little packs of dog poop that people have left behind. They think they're going to pick it up on the way back down, but they never do. To model these things, all this water stuff realistically in computer requires complicated math that generally takes tons of computation, and usually results in a terrible frame rate. If you want to implement Navier-Stokes equations, knock yourself out. A lot of physics engines start to glitch out really easily. It's very difficult to do this in a live, high frame rate environment. And it's not just rendering one thing, it's all rendering it so that it can be viewed from a variety of different angles. Ends up being a very difficult task. Fortunately, video game design is mostly about finding shortcuts and really horrible hacks to do that look okay in context without having to construct a whole reality simulator. Many video game programmers start out wanting to let the physics engine do a lot of the work for them because they think, oh, I'll just define a few rules and then we'll just have a sandbox and it'll be great. And sometimes it is, as long as you understand that physics engines will glitch out. And if you're trying to tell a particular story, if someone's walking along and suddenly they're launched out at 50,000 miles an hour or something, that could be fun, but maybe not quite on topic for what you want your vision to be in the game. Also in video games, you don't have to stick to a completely realistic appearance. If you pick to a particular art style and stick to that, you can hide all kinds of like actual physical details and mostly get away with it. It comes back to what kind of experience are you trying to convey? What kind of behavior in an ecosystem are you trying to highlight? When I've been out hiking, I'll usually come back with a lot of photos. I'll usually process them with Darktable. That takes raw files from cameras and processes it with filters. And sometimes I'll pull out a splash picture or take a little video of water splashing around. You can use that as a card on a particle, or just use photos as source images for 3D modeling. So let's start to build a basic waterfall. This is the easiest way to represent kind of a basic waterfall, is just a plane that's bent over a surface with a texture put onto it. then if you scroll this texture, a lot of video games, that's pretty much all it is. They might put a little fade or a little extra light effects on it, but this is like 80% of video games or video game waterfalls that you might see. And I've been doing all my projects lately in the Godot game engine, which is free, open source, cross-platform. It's very easy to use, especially for small teams. I like it a lot. It's making this texture scroll is very easy to do in Godot. The default shaders, it doesn't really do time-sensitive stuff like this, but you can convert a basic material into something that responds to time with a shader. So, like with this, there's a standard material that has like reflectivity and roughness and how things reflect and stuff like that. You can take those basic things that you can toggle things on the side in the inspector and then convert it into shader code. And then you can just go into the shader code and add little things that you need. For instance, to make the stuff scroll, each mesh has a face that has a 2-dimensional coordinate that maps onto a texture. So if you take that UV coordinate, the Y coordinate, and make it just literally add on time, then you can make the entire texture scroll along a plane. And there's other things you can do instead of just scrolling on a static, like a flat mesh, is particles. And particles can give you some 3-dimensional effects. There's a lot of things you could do with particles. If you layer too many particles, you start to run into the same frame rate issue, and people will complain. There's many different ways you can use particles, like especially splashing on the ground or splashing off of rocks as water tumbles down over rocks. One thing particles can do automatically in Godot is respond to gravity and other forces. Like you can put up force effects to make particles fly around according to some physics laws. So it's not entirely realistic physics, but it's basically like simple forces acting on it. But I found that sometimes I want waterfall particles to follow a particular path that's not actually realistic. So that's another thing you can do with shaders, is define a path for things to follow. This, for instance, is a shader that you can put in a Bezier path, which is basically just 2 points with 2 handles in between, and then move those points around, and then have the particles, the little splash particles, follow that path around. Sometimes a waterfall goes over the side of a cliff, so if you just use gravity, the particles would go down, and you have to do all sorts of annoying stuff to do colliders so that the particles know when to bounce, and it's really hard to set up. But if you can just define, say, I don't want just a normal gravity parabola, I want it to go slightly off-center or slightly like a little dip in the center and then go out. It's very easy to do if you can just modify your own path in the shader. So scrolling textures, meshes, particles, those are kind of the building blocks of layering up waterfalls. Most video games use various combinations of those, that and also highly skilled environment artists. In any case, manually building up waterfalls takes a long time, even with highly skilled environment artists. If you want a new waterfall, that would mean going back to Blender, making a new mesh, then exporting from Blender, importing into Godot, setting up materials, and it's highly cumbersome. It takes a long time. So to address that, I've been working on a tool that lets you automatically plop down waterfalls into geometry in a Godot scene. I've seen, it's like I said, textures, meshes, and particles are kind of the basic building blocks. I've seen some other techniques where you make a kind of a noise, a 3D model of noise basically, and then have that, just like you're scrolling a texture, scroll the actual mesh with a shader. So you can get really fancy. I haven't built one of those yet, but it's on my to-do list. So the tool that I've been working on, also in Godot, Godot has many ways that you can add tool functionality. So like you can have one script that you just tell it to run and it does stuff, or you can have a script that runs in a viewport. It's done with objects. Like Blender has objects in it that you can move around and scale and stuff like that. And Godot has the same concept. You have just objects sitting in a scene, and each object every 60th of a second or 90, whatever your frame rate is, it'll do some other activity. So there's special objects that you can have run in the editor that you can move around in the editor. So you can define paths for waterfalls, for instance, and all kinds of other like tool things. You can also define your own menus and other little docks. You can define an entirely new viewport interface if you want. Godot is extremely flexible in adding custom tooling, and which is fabulous for artists. A lot of open source art software, some have a lot of tool features, like Blender, you can do a lot of custom tooling. Krita, you can do a fair amount. Inkscape, like for 2D stuff, you can do some under very specific circumstances, but Godot has a multitude of ways. It's other open source art software could really learn from that. Also, Godot has it's a little bit controversial sometimes, but there's one tab in here that's for, not sure if I got it in that screenshot, for the asset lib. If you make an add-on with all of your fancy tool or resource collection, Godot has a built-in way for you to distribute it to other people with a built-in tab for an asset library, which is kind of convenient. I've made a couple of add-ons distributed that way. This is one that I wrote just to pile on a bunch of objects in Godot. It uses kind of I was supposed to be a repeating video. It uses a hack that you can do in the Godot editor by turning on physics. Normally the physics engine only runs when you run a game from Godot, but if you turn it on in the editor, you can just dump a bunch of objects and it looks a little bit more realistic. You have to be careful if you turn on physics in the editor though, because if you set up a character that has some physics objects to it, sometimes the character will sink through the floor and like fall down to negative infinity, and if you do that hack, you can't really undo exactly. So you got to be careful. I know this from experience. You can also do something like that in Blender too. Blender has more like officially built-in simulations for like simple physics, and has better undo support if you do that. So the first method for generating waterfalls that I tried was using that physics hack, just by taking what's called a rigid body and dropping it onto somewhere that has a slanted surface, and then just sit there and watch the balls roll. And then based on where those balls are rolling, just slap on a mesh in between all of the paths, which works pretty well. Since it's using the physics engine that runs basically in real time in the editor, which is cool it's cool to watch for the first couple of times. But then if you want to rapidly iterate and move paths around, it gets kind of annoying because it's so slow. You have to wait in real time. It takes forever to do that. So this is my first method to do that. I've moved on to another method using what's called a character body 3D in Godot. It's another type of physics object that can interact with rigid bodies and other physics objects. But how the character body actually moves is you have to tell it to move. So like forces will act on it. You can add up all the forces and you'll get a signal saying, okay, it's going to move in this direction, but it's up to you to actually move it. And you can do that process as many times as you want per frame. So you're not tied to actual real time to see where a ball is moving. You can just like make it run 50 times and fill out a path like this very easily. This method works pretty well. I have to optimize some of the results still. Also, if you move the path just slightly, the lines really flip around. I think that's kind of due to colliders are the things that tell you whether or not you can go through something, because what things look like and how things bump into each other are different concepts. So visually things get smoothed out, but collision shapes do not get smoothed out. So if you move the path right next to something that has a hard surface, the path will hit either side of that surface and bounce off in very different ways somehow. So I'm currently working on a third method to do something similar to the character body, but do manual ray tracing. So like it's kind of a lower level of making a ball go forward. And have a spread of ray casts. So instead of a ball just bouncing off and hard surfaces sending you astray, if you have a few samples, then you can kind of average those out and get it kind of a smoother flow, hopefully. But I didn't quite get that functional before today. Yeah, one way to correct for that. It's another consideration for dropping basically water balloons on a scene and seeing where they go is how to spawn them in the first place. My tool currently has a couple of modes for doing that. One way is just drawing a line. It spawns balls along that line and then lets them go, which works pretty well if the water starts out really hugging rocks. But if you have a river that's dug into the cliff top, it makes it kind of a dip. So if you do that, then you're spawning balls kind of in a U shape, which is kind of not really what you want. So there's a separate mode for spanning. So you draw a path and it takes the first point and the final point, and then tries to sample directly below the midpoint for what direction water should flow in that river, which works much better for rivers that have depth through them. So that's kind of how you get paths for a waterfall. And if you want to layer things up, I currently have a bunch of inspector boxes to fiddle with different settings for materials and whether you have one mesh or another kind of mesh and other particles and stuff. When I do tool design, I tend to want to make tools that have little gizmos in the viewport, just because they're more intuitive. I kind of hate, especially if you have a big monitor, if you're working on something, it's kind of disruptive to have to go all the way to the side of the screen and mess with stuff and then go look all the way back and see the updates. But if I have some gizmos in the screen, that kind of makes more sense. That's my goal. But at the moment, it's 90% just a bunch of boxes with numbers in them. So a note about mesh layering. Like before, there was mainly just a single mesh that spanned all of the paths. But one way to add more detail is per path have like a little fan mesh that goes over it. Then you can, with a shader, from that path, make it kind of bulge out on the bottom, and then as a function of time, kind of make it wave in and out. So each of those ball paths will have its own separate little mesh that's kind of dancing around. I first saw that method in a fabulous waterfall tutorial by Ghislain Giardo, except his tool is only for Unreal, so I can't use it. It's kind of why I'm making my own, just because I wanted it in Godot. If you layer up meshes visually, it's kind of a huge issue too, especially if you're using transparent textures. Because when you render transparent textures in Godot, they're basically kind of one after another, and the order that they go one after another is sometimes counterintuitive. Like when I'm spawning meshes here, they all tend to have the same object origin, and the ordering is usually determined by distance from the camera. But if they all have the same technical origin, then the compiler just makes its best guess about which one should be drawn first. And if you have a bunch of meshes that are like flopping all around and going in and out of each other, it makes it very difficult to have a visually consistent display of meshes. And it's a little subtle. I'm not sure if from the projector it comes out, but if you look from one direction, it looks good with one blend mode. With another blend mode, one mesh might pop out of another one, depending on what angle you're looking at it. It's really noticeable, especially if you have intersecting planes, because then how do you determine which one is rendered first? It's very difficult to have a consistent way to render those. There's a blending mode in Godot called blend add. If you've ever used Inkscape or InDesign or whatever, they usually have a whole bunch of different rendering modes, like mixing different ways to combine alpha values. Godot has a few. Blend add is just taking a transparent value and stacking it onto what's ever there. So as long as you keep your meshes down to like a few different meshes, you can add on a bunch of stuff. And waterfalls are nice because they're mostly white. So you can stack on a few and it still looks pretty good. So that's kind of how water falls down. What happens when water hits the ground? Right now, whenever a ball penetrates the surface, you can define an area of water. So each ball path that hits the water makes another point on the water surface, and then you can connect all of those points, and then construct a mesh that's basically all the UV coordinates are pointing away from that line at the bottom. So the texture at the bottom is just the basic noise in kind of a rectangle that's been squished all around that line. So it's a very low-cost way to have a basic scrolling. You don't have to mess with particles. It's just a single mesh. Another way that you could be able to have something like that, a pattern, an interesting pattern on the bottom, is to construct a flow map. And flow maps are really convenient. They were first like publicized as a procedure in Portal 2 by Valve a long time ago. It's basically where you take an image and define directions and bake those into a single texture. So if you have colors go from 0 to 1, the middle of that color, 0.5, would be not moving. If you use the X and Y value, red and green, to be X and Y directions for things that should flow, you can sample, for each point in an image, take that as a direction, and then sample a point that direction away from your original pixel. And then you kind of can get some swirly stuff like on the other side. If you apply that to splash particles and bubbles or water going down, it's a very easy way to get some pretty fancy textures out of some very simple geometry. So you don't have to tell the renderer to do this one thing a million times, like a million separate calls. You can just do it all in one call, saying, here's this shader, perform this action a bunch of times. It's more efficient than breaking things down in more complicated ways. It's worth mentioning that you can draw these flow map direction patterns in Krita, also open source graphics software. Krita is mainly designed for painting. It comes with numerous brush engines in Krita. This particular one is the tangent normal brush engine. By default, the direction that it draws is defined by the way you tilt a pen on a tablet. But if you don't have a pen and a tablet, you can also do it with a mouse. You just have to set a tangent tilt setting to direction, and then you can paint flow maps with a normal mouse. It's really convenient for roughing out flows. And this is a kind of a comparison between different like scrolling techniques. Just scrolling, or you can have a flow map with two different samples on the far end over there. The middle one is kind of like faking. If you're in a hurry and you can't remember the math for flow maps or something, then you can take two samples of the same image and then just have them scroll at different speeds. And depending on your circumstances, one might be just easier to hit your deadline or whatever. There's a lot of different ways you can apply different scrolling. If you're up close to something, you don't have to do as much attention to it as if something is like half a mile away. Just depends on what you think you can get away with. So that's kind of where my waterfall tool is. It's still a work in progress. You can't have waterfalls usually without a river coming up to it, unless it comes out of a spring that flows underneath in the rocks. So I'm working on a river generator also, so you can define a path in Godot in the editor and drag it around and have some refraction with the ground and stuff like that. But I still have to connect that river thing to the actual waterfall. So it's another one of many features I didn't quite have completed by today. Other things still to do is connecting audio. I've also been recording videos of waterfalls I've gone to visit, so I also have tons of like unencumbered by copyright sounds of waterfalls, which is convenient. Other stuff like splashes on rocks, collisions and puddles and stuff. My intention is to collect this waterfall tool with other procedural generation tools I've been working on and release them basically as open source for other people to block stuff out or use in their own video games. And this plant, by the way, is bear grass. The last few weeks up around Mount Hood and in the gorge, there's been a huge preponderance of bear grass blooms. It's been pretty amazing. So I always love to see they look like little alien pods. So it's a very nice flower. This bear grass here is also procedural, as well as all of the grass strands. That's all done with a shader. So it's taking each strand of grass is just a vertical line, and the shader is taking those and bending them down and making the stalk go according to certain angles and heights and randomness and stuff. my intention is to take these tools and kind of flesh them out into a traversable game where if you wander around scenes like this, then the goal is to provide ways to dig into the shader code so that you can learn how to do this stuff by playing the game. A friend and I are back home, I guess here at home, have been working on this concept. It's kind of a game that teaches you how to make video games for a couple of years. We have a lot of individual pieces, but not quite a coherent releasable project yet. We like working on new stuff, so as soon as we figure out how to do something, we tend to like go figure out something else, which in terms of getting things done is not a good trait to have, but it's fun. No one's paying for us too, so our development schedule has been a little haphazard. A little bit of cars. And this was kind of a roughing out of, kind of a blocking out scene using it's kind of combining two different waterfalls in the gorge, Odeonta Gorge, where you used to be able to go along the gorge at the bottom. Now there's a huge log jam, plus there was a big fire, so lots of like dead tree trunks are falling into the gorge all the time, so it's a little dangerous, allegedly. And then the waterfall at the end was kind of Punchbowl Falls, the same trail as Eagle Creek. This character is not open source. It's from Mixamo. Adobe has it bought Mixamo somewhere along the line and provides a lot of free to use but not open source characters. So right now that's just kind of blocking out. Another thing on my to-do list is to make characters of my own to have something reasonable instead of blocked out stuff, but that's another story. And I guess that's it. Go waterfalling, go waterfall hunting, make art.